Hello everyone, welcome back to the channel. So today in this video, we are going to talk about a little harder problem on the array. Okay, so far we have discussed some algorithms specific to array, but those were kind of easy to medium level. But this is something which is little harder. Okay, but yeah, if you apply the logic properly, we can easily understand how to do it. Okay, so what we are going to do is first we will understand what the problem statement is. And as usual, we will first try to get a working solution. We'll understand the time and space complexity for this. And then we will see how we can basically optimize it. And we will see with a Python code for it. Okay, so let's understand the problem statement first. So what this problem statement is, okay, so if you see the heading, it's saying trapping rainwater. Okay, so let's first understand. So what we are going to get is we'll get an array. Okay, an array has some elements. So what we have to do is kind of just to get an understanding, we have to just draw an x and y axis, and on the x axis, whichever element you see as per the value, you have to just draw a line. Okay, so like for example, first element is 0, so there is nothing is there. Okay, second element is 1, so you have this black box you can consider. Third element is 0, so this is basically an empty like the first one, but uh, the ask is basically to see where we can store the water or how we can trap the water, where we can trap the water. So this is a section where we can trap the water. Okay, so this is initially it is empty. So you can consider this blue, whatever the blue section is, you can consider that as an empty. Okay. Then the fourth value is 2. You can see 2 boxes. Then 1, 1 box. Then 0, so empty. Then 1, 1 box. Then 3, we have 3 boxes. This way, for each of the value, we have to kind of draw the boxes. And then whichever section, okay, excluding the first one, okay, because there is no wall on the left hand side, okay, even though you see it as a y-axis, but there is no wall, that's why we cannot store the water there, right? So whichever section you see that as a blue, okay, that's where we can store the water, okay? And then we have to calculate like, okay, how much water we can store. So each box, one box, we can consider as 1 unit of water. So how many boxes we have? 1, 2, 3, 4, 5, and 6. So total 6 boxes of water we can store it here. So that's what we need to calculate. Okay, so that's the main ask. So if you see another example, let's take this as a kind of array, and let's try to understand, okay, if how much water we can basically get it. Okay, so we have a value 4 to 0, 3 to 5. So let's go back to the whiteboard and try to understand. So array is 4 to 0, okay, and then 3, 2, and 5. Okay, that this is basically an array. Okay, 4 to 0, 3 to 5. Let me just confirm once. 4 to 0, 3 to 5. Okay, so now let's try to draw it. Okay, so let's say this is 1, this is 2, this is 3, this is 4, and this is 5. Okay, so first one is a 4. So let's say this is the first. Second is 2, so this is second. Then 0, so we don't have anything. Then 3, so 3 will come here. Then we have a 2, so which is again come here, and then 5. Okay, so 5 will come here somehow, right? So now, which section is something that where we can store the water? Okay, so now if you closely look at it, now here on the left hand side we don't have anything. So here, now between this is the lower section. Okay, then this whole part is empty, so we can basically store the water here. Okay, so this section where we can store the water. But then again, here, this particular section is empty. Okay, so this is a 2, and then we have a 5. Okay, so this 5 is here. Now this is filled, right? So this is the section where we can store the water. And then another section is this is 3, right? So between 3 and here 3. Okay, so this section, okay, we can again store the water, right? Anywhere else? So here we have a, this is 3, right? So this section also we can store the water. So that's it. Okay, so this is where, okay, in fact this is also 4, right? Now between 4, this section also we can store the water actually. Okay, so how much water we can store? Let's try to understand. So how many boxes we have? 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. Okay, so is that a correct understanding? Let me just check it, what they have mentioned. So they are saying it as a 9. Okay, they are saying it as a 9. So let's recalculate if we are giving it correct. So 4, let me just use a different color. So this is a 4, then 2, then 3, then again 2, and then 5. Okay, so that means this should be fine. Okay, so we can definitely store the water here because here we have a 2, right? So 3, 3, and 4, 4. So this is 2, this is 2, this is 3, and this is 0. Okay, so here definitely we can have a 2 boxes. Then this is 2, this is 2. Okay, so that means total 6, 7, 8, 9, 10. So it's actually a 10 boxes. Okay, I'm not sure why in the input they have given it as a 9, output as a 9. Okay, so there might be some mistake. Okay, so that's completely okay. So this is what we need to identify. Okay, now how we are going to solve this problem? Okay, we can with the problem statement we'll get to know. Okay, when we solve it, we'll get to know whether whatever calculation we have done is correct or not. So how we can solve this problem? Okay, so to solve this problem, basically what we need to do is, let's say you have uh, basically a pointer 1 here. Okay, and you want to basically, let's say you start with a element which is here. Okay, that's a pointer 1. Okay, now what from this what we can understand is, let's say these are the two lines. Okay, this is a 4 and this is 2, right? So now between these two column, where we can store the value? Okay, we cannot store the value. Okay, if here we have a 4 length and here we have a 2 length, so we will be able to store the water only on the lower side. Okay, so now if you talk about this, let's say 4 and this is a 5, right? So now between these two, where we can store the value? Okay, we cannot like fill the water till 5, we can fill the only till the minimum value of it. So if you are comparing two edges, then we can store the value, store the water only till the lower edges. Okay, so between this, let's say if your P1 is here and P2 is here, you need to consider the minimum out of this. And then out of this minimum, we can see how many boxes where we can store this. Okay. So what we can do is, okay, what we can do is, we can have a, let's say position P. Okay, position P. And then we can see on the left hand side, is there any age which is greater than the current age? Okay. Is there any age which is greater? Because if it is a greater, okay, like let's say this is the array. Okay, and then if you have, let's say this, then let's say this, okay, then small, then greater, right? So how we can store the basically water? If this, let's say pointer is here, now this is a P1 and this is a P2, right? So we can basically find on the left hand side which is the maximum height, and also on the right hand side which is the maximum height. And between these two maximum heights, on the left, max left and max right, okay, whichever is the minimum, then we can kind of draw the line. And then out of this, like let's say we are doing it for this particular position, okay, out of this height, we can basically subtract the current height. So current height is, let's say 2, right? So total is basically, out of this is a 4 and this is a 5. So out of this max left and max right, we have to take the minimum, that is 4. Now out of 4, we have to subtract the current height, which is, let's say 2. So 4 minus 2, that's 2. So that means this is the 2 boxes, that's where we can store the water, right? So that's something we can calculate it as a total water. Okay, let's say right now here is a 2. Now here, If it is a 0, let's say this is a 0, right? Now if your P is here, now on the left hand side max is 4, then on the right hand side max is 5. So between these two, what is the minimum? 4. So 4 minus the current value is a 0, right? 4 minus current value is 0. So 4 minus 0 is 0. That means this whole 4 boxes we can store it. So this way, for each value of P or each position, okay, we have to first identify what is the maximum value on the left, what is the maximum value on the right, and between these two, first of all, we need to find the minimum out of these two, and then out of that minimum, we have to subtract the height. We will be able to get the how much water we can store for that particular bar. Okay, this way we need to go and do it for each position. And then we need to keep adding it to the total water, and we should be able to get the how much total water we can store. Okay, so let me first try to write it and I'll then explain again. Okay, so I have this earlier solution. I'll just remove this. Okay, and let's try to write it. How we are going to write it? First, we'll take a for loop. So for P in range, where the range is length of height. Okay, so this is just to move our position. Now what we are going to do is we have to initialize some position. Okay, so first of all, I'll take P1, then P2. P1 is to basically go on the left hand side to check the highest edge, okay, or height of the edge, high max left, and then P2 is to go to right to find the max right. Okay, or we can take that as the variable name, like max left and then max. Okay, so that's basically we can say it as a left P, left pointer, and then right pointer. Okay, and then both I'm going to initialize as the P. Okay, both I'm going to initialize as the current value, current position. Okay, also I'm going to do is max left and max right. Initially I'll initialize as a 0. Okay, and then let me do one thing here. Out of this for loop, I'm going to say it as a total T water. T water is nothing but a total water is a 0 for loop. Okay, now what we're going to do is from current position on the left hand side, I'm going to find the max left. Okay, so how we can do it? While left P, okay, left pointer is greater than 0 position. Okay, while greater than equal to 0th position. Okay, if and what we need to do is we have to get the max left is equal to max between the height of left position, okay, and the max left. Okay, so whichever is the maximum, the current height or the maximum left. Okay, so we'll declare it as a maximum. And then if the apart from this, what we need to do is we need to do left pointer, we have to just subtract it. Okay, so minus equal to 1. That's what we're going to do. And then another thing what we need to do, another while loop, while right P is less than the length of the height. Okay, we have to go on the right hand side as well to find the maximum. So HEIGST height, what you need to do is max right is equal to max between your max R and the height of right, okay, right point. So out of this, whichever is a maximum, we'll assign it to max. And then what we are going to do is right pointer. Now we have to forward, go to forward. That's why I'm doing a plus. Okay. And then once we reach it, we have to find the current water, how much water we can store. So how we can get it? A minimum between a max left and the max R. Okay. So between left and the right, whichever is the minimum. And from that, we are going to subtract the height of, okay, height of the current position. That's the P. Okay, height of the current position. That's it. So this will give the current water. And if the current water is greater than 0, what we're going to do is a total water we are going to increase. So total water plus equal to current water. Okay, so that's the solution. Okay, so if we go ahead and just run this, okay, what you would, it will give us the total water required for this, whatever the input we passed. Okay, so let's try to run it and see if it is passing. Oh, sorry, I have not returned actually, so it should fail. So let me just return. So return is equal to total water. Okay, so let me just run it now. So let's see if this is passing the test cases or is there any issue. So yeah, it is failing. Okay, yeah, I did some mistake in initialization. So basically here two values are there. So I should do 0, 0. Okay, let me run it. This time, let's see what we are getting it. So you can see both the test cases got passed. Okay, so let me see what is the other test case. Is it the one that was showing there? Okay, yeah, you can see somewhere I think while in our calculation that was wrong. So, but yeah, you can see current, our code is correct. Okay, so it's giving correct, like current is 9, I mean, output is 9 and expected is 9. Okay, so both these test cases got passed. But now let's try to understand the time and space complexity. So you can see time complexity, you can see this loop is running for all the n values. Along with that, the while loop, okay, inside the that for loop also, okay, we are running, the one pointer is going on the backward side, one pointer is going on the forward side. So this is also completing kind of a n operation. So that means the time complexity for this is we are getting it as a n square, which is too high. Okay, space complexity, you can see all these are kind of a constant variables. Okay, there is no variable which is growing as we grow. The number means as the array is growing, none of this variable is growing. So your space complexity is big O one only. Okay, so space complexity is not an issue, right? So now how we can optimize this? Okay, that's something we are going to understand, because here the time complexity right now is a n square. Okay, but how we can reduce it? So let's go back. Okay, and let's try to understand. Maybe what I'll do is I'll just rub this and then let's try to understand. Okay, so what we can do is, let's say this is your array. Now here we have is 4. So 1, 2, 3, 4, and 5. Okay, so these are the 5 total values we have. And now what we have to do is, the first value is 4. Okay, so first value is 4. Then we have a 2. Okay, then we have a 2. Then we have a 0. Okay, and then we have a 3. Then we have a 2. So this will become something like this. Okay, 2 is here. And then we have a 5. So which is till it will go here. Okay. So 2 and 5. Okay, so that means you can consider something like this. Okay, so now where we can store the water, it's something like this. Okay, so here we kind of having 2 boxes, here 2 4, then this is 5, and this is 4 5 6. Okay, so I think somehow we are missing that calculation, but yeah, that's fine. So now here main thing to understand here is how we can basically improve the solution. Okay, so to improve the solution, what we are doing is we are running through the loop 2 times. Okay, so to avoid that, what we can do is we can have a one pointer on the left, one pointer on the right. Okay, and what we can do is, as per our previous example that we have seen, where we are kind of just moving this pointer only once. So what we can do is, whichever is the pointer is the less. Okay, so height here is, this is a 4, this is 5. So which one is less? So 4. So 4 we can move forward. Okay, here first of all we can have a total water is 0. Okay, then we have a max left 0, max R 0. Okay, and left. So first of all, we need to get the minimum of this pointer. Okay, left or right, whichever is the minimum. So minimum is left one. That's a 4. Okay, so max left initially 0. Now it is 4. So this is 4. Now max right. Okay, max right is 5. Okay, so what we have to do is for this particular position, what we need to do is how we can calculate the current water. We can basically do what we have to do is we have to first of all identify the height of the current. Okay, so what we can do is the current position. Okay, what is the current position? It is 4. Okay, the current position is 4. So height of total is like it's a max left is a 4. So 4 and current height is 4. So 4 minus 4 0. So here we cannot store anything. Now for the next, okay, so we'll as this is a smaller value, we move our P1 forward. So P1 is here. Now the current height is 2. Now 2 and 5. Which one is the smaller? 2 is the smaller. Okay. And what was the max left? It was 4. Okay. So 4 minus current height, that's a 2. Okay. So this is the current water. We can store the current water as a 2. So total water becomes 2 for me. Then now we can move forward. Okay, so the current here, we can move forward here P1. So current height is 0. So 0 on the right hand side, it is 5. So which one is less? This one. Okay, now max left is 4. Okay, so 4 minus 0, so 4. So here 4 plus 2, this becomes 6. Again, we can move forward here. This is 3. So 3 and 5, which one is the smaller? 3 is the smaller. Okay, but max left is 4. So 4 minus current height is 3. So that means 1. So we can add it here. That becomes 7. Okay. Then again, we can move forward. Now forward from 3, we can move forward as a 2. Okay. So this is 2 basically. So 2 is the current height. So max left is a 4. So 4 minus 2, that becomes 2. So 2. Okay. We have a 2. So basically 4 minus 2, that becomes 2. So 7 plus 2, that's a 2. That becomes 9. That's it. So we reached finally here. Now we can't have any more water here on the right side. Okay, because we have reached it. So that's where we are getting a 9 as the value. So this way we have to basically in a single traversing itself, we should be able to get that the total water that we are storing. Okay, so let's write the code now. Okay, so let's write the optimized code and see how much we are getting it. Okay, so what I'm going to do is I am going to write. So now let's first I have to rub this. Now total water we have to initialize 0, then also max left and then max right. Both I'm going to initialize it as a 0. Then what else? The pointer 1, P1, I'm going to initialize as the 0. P2, I'm going to initialize as the length of height. Okay, length of height minus 1. Okay, and now what we need to do is while P1 is less than P2. Okay, we have to go till here. Okay, now what we have to do is we have to check which one is the lesser. Okay, so we have to check if height of P1 is less than height of P2. Okay, if that is the case, what we need to do? We have to do if max. Okay, so if height of P1 is greater than max left. Okay, if that is the case, what I'm going to do is max left is equal to we have to do height of P1. Okay, we are just updating the max value. Okay, otherwise else if not max, what we can do is we can just simply do a total water is equal to max L minus the height of the current cell. Okay, what is the height of P1? Okay, so this is for the left hand side. Right hand side, what we are going to do is else Okay, apart from this, we have to advance our pointer, right? P1 is equal to plus equal to 1. Okay. Otherwise, else, what we are going to do is if height of P2, okay, is greater than max R. Okay, on the right hand side, if it is a maximum, what we are going to do is max R is equal to height of P2. Okay, height of P2. Otherwise, what we have to do is total water plus equal to a max right minus the height of P2. That's it. Okay. And once all this is done, you have to just simply return the total water. Okay. Okay. One more thing I left is we have to decrement the pointer P2. Okay. So minus equal to 1. That's it. So let me just run and see if it works. So it should work. Okay. I think looks like test cases got failed. So something we are missing. Let me just check it. So output is 14, expected is 6. Okay, let me just verify quickly if I'm missing anything. So we have initialized all 0, 0. What we are checking is if instead of a less, let me just do not equal to height of, oh, sorry, I have done here 1, 2. Instead of that, I have to do P1 and P2. Okay. So let me just now run it. Perfect. So now it got test cases got passed. And even if I just submit it, we should be able to get a better solution. Okay, so you can see this solution is better than 90, almost 97% of the people. Okay, so what we have done is, okay, instead of running through 2 times in the that particular array, okay, we are just kind of shifting the pointer. One pointer we are taking it on the left hand side, one pointer on the right hand side, and then we are keep shrinking it. While shrinking it, we are calculating the some values like, okay, what is the max left value, what is the max right value. Okay, and here one important thing to understand is basically we have to choose the minimum, okay, minimum between the two heights, because till that minimum height only we can store the water. Okay, we cannot just go and basically store the highest value or a maximum value, because water will overflow, right? So we have to just choose the minimum value to where we can store, right? Like let's say here, if we are having it between this 4 and this 2, okay, so we can store, we have to consider the minimum till 2 only. We cannot fill the water on top of this, right? So if let's say between a 4 and 5, okay, so 4 and 5, we can just choose the minimum 4 only. Okay, we cannot choose 5 because we cannot store the water more than this level. Okay, so between 4 and 5, minimum value is 4. And then if the uh, current value is this 2, what we have to do out of this 4, the max left, we have to reduce this 2 so that this 2 boxes, that's where we can store the value. Okay, so it's a very simple solution. Okay, we have to just think on how we can solve it, and basically we can get it. Okay, so here you can see we are getting almost better solution than 97% of the people. And then again, if you talk about the now the time complexity, we are just running through only one loop. So here we'll get the big O n only. Okay, so time complexity is n, and even space complexity also it's a just a log 1 only, because it's a, in fact a big O 1 only, because we are not storing any storage where that is going to increment. It is just one value we are storing. Okay, so even space complexity is 1. Okay, so that's it for this video. Okay, so I hope everyone understood. If you have any question, please put it in a comment. Okay, we'll definitely revert. So that's it for this video. Thanks everyone. I hope, and if you like the video, please do subscribe, share it with your colleagues. Okay, so that's it. Thanks everyone.